Are there anything that you looked at that you are still unclear of? Okay, let us then continue. Let me clear everything that we have here. And next we'll turn my focus to the cantilever slab. As per the notes that I've submitted, the cantilever slab. Now, we all know what a cantilever is. We know what a cantilever slab is. Cantilever slab is something that is not fully supported on all sides. It is supported and partially, and it is supported on one side and not supported on the other end. Meaning that the design would have to be correct, and that is something that the engineer would design, something that you would have done in structures. And if I look at section BB, that shows me the cantilever slab. And the cantilever slab in this instance, I trust that you can see where the cantilever slab would be placed on this drawing. The cantilever slab would be placed over there. This here being the outer edge of my cantilever slab. Can we all see that? And when I look at this, there's something very important that we need to take note of. It tells me that over there my dimension is 100 millimeter. And what is the thickness of my slab? 150, right? The thickness of my slab is 150, as is illustrated over there. It means that from there, where it's 150 and going to 100, it means that my slab is breaking. It means that my slab is breaking. And that we will transfer to my description. So when I look at my cantilever slab, it will then be reinforced concrete 20 MPa 19 millimeter stone in slabs, beams, and inverted beams. Same description that I've had previously for my slab. Excuse me. And multiply by the depth, the thickness of 0.13. But you might say, but sir, where do you get 0.13 from? I get the 0.13 from taking the 150, the thickness of the slab, where the cantilever slab starts, and I add the 100, which is the final thickness of the slab at the end of the cantilever slab, and I divide that by 2, and that gives me 125 millimeters. Now, when I write 125 millimeters as an exponent in linear meters to 2 decimals, it will be 0.13. Now, I have illustrated that in my first column of my description. So it will be the thickness of 0.13, and I will then have a formwork to raking soffits of slabs, including propping up, exceeding 1.5 and not exceeding 3.5 meters high from bearing level. Again, that is what I would use my bearing level, using my ground level at my bearing level, and my dimensions then would be 14.22, which is the overall length, from there, the outer side there, and multiplied by 1.5, which is indicated to me over there. I'm happy with my cantilever slab. Right. We're all happy. Then I look at my formwork to the edge of my slab not exceeding 300 millimeters high. And the formwork to the edge, clear that again. Formwork to the edge of my slab would then be simply given to me there, there, and there. The formwork to the edge of my slab, you'll see my description says not exceeding 300 millimeters high. Because the thickness on one side is 150, the other side is 100. So it will fall, and the standard system tells us that when it does not exceed 300 millimeters high, it will be measured in meters. So it will be measured in meters, and I have 14.22, which is that, and then I have 1.5, that, and that. So there's two of the 1.5. But at the same time, I have over-measured my formwork to sides and soffits of beams. When I measured this dimension here, measured that in my formwork to sides and soffits of beams, I now need to deduct that there because there's no formwork that would be placed over there. And everybody see where I'm showing where I will be deducting my formwork to sides and soffits of beams as before. So it will be 14.22 multiplied by 0.15, which is the thickness where my cantilever slab meets my existing slab. All with me? You all with me? You see that?
Yes, sir, I see that.
Okay. And that brings us, guys, to the end of the cantilever slab. There's much to take in. There's much to take in. I do not know, do you guys have time tomorrow morning? Again? You guys have time tomorrow morning? We can do this at the same time tomorrow morning again. I can do the staircase, which is quite involved, as well as William's adjustments for his openings.
So can I just ask you a question with regards to the project 2? I saw here, just in some brackets, it says excluding the staircase. So does that mean
you don't have to measure? You don't have to do the staircase.
Okay. Right, thanks. And then just a quick question, never mind, we'll do it tomorrow, but I wanted to ask about formwork on a circle for the deduction, the adjustment. Never mind, we'll do it tomorrow.
Okay. All happy with that? That we do that. We do that tomorrow. Again, as I say, it is quite involved, and as you guys could see now with the beams and all of that, it gets quite involved in that. And we can meet same time, same place tomorrow morning, 8 o'clock. I will put up the invite for that. We're all happy with that. All happy? Cool. Cool bananas. I take it with no one saying objecting to it. We will do that. Meet at 8 o'clock tomorrow morning again. Have a blessed day further, guys. And we will meet up tomorrow morning. Thank you. I have to go and get ready to go to a funeral now. Thanks, guys.